We scan the skies for radio signals and oxygen, expecting an advanced civilization to announce itself. But a mature interstellar presence requires closed-loop thermodynamic infrastructure, not biological communication. Instead of generation ships, we find the Managed Non-Equilibrium Asset, or MNEA. An MNEA is an automated logistics node engineered specifically to resist geologic entropy across transit windows that last for eons. When one of these objects transits our solar system, standard automated survey telescopes observe an entirely inert rock. The outermost hull inner is a porous envelope of silicate and carbon, known as metric ash. This skin operates under strict albedo management protocols, maintaining a constant 0.04 reflection rate to completely hide the high-density metallic substructure beneath it. As the object approaches a star, it vents carbon monoxide and carbon dioxide. This controlled outgassing perfectly mimics the 130 Kelvin thermal inertia profile of a natural celestial body sublimating in the sun. By perfectly replicating an inert, naturally decaying comet, the asset successfully evades detection by our current deep space search algorithms. Beneath that layer of ash lies the refractory bus. The true architecture of the asset is a pre-stressed, monolithic hexagonal lattice. This lattice is composed of isotopically pure nickel-62. As the most stable nucleus in physics, nickel-62 provides maximum radiation shielding and the structural resilience required to survive massive tidal forces during deep well gravity assists. This scatter plot compares expected natural isotopic baseline abundances against the composition of a detected object. We use an artificiality filter called the isotopic drift index, where a value exceeding 0.5 indicates artificial refinement. Here, we see a massive spike representing a nickel-62 enrichment 120 times higher than the solar baseline. When we run forensic audits on recent interstellar visitors, the drift index hits 0.85. A concentration at this level requires advanced, industrial-scale refining. A structural isotopic drift of this magnitude provides a definitive mathematical signature, separating an engineered transit vehicle from a natural accretionary crust. Moving inward, the space between the refractory hull and the central core contains the mantle. This is a pressurized high-performance cryogenic reservoir. The mantle consists of superfluid helium-3 maintained at a base temperature of 1.2 Kelvin. Helium-3 is exceptionally rare in natural planetary contexts, and its presence at multi-ton scales serves as a strict marker of an engineered logistics chain. In its superfluid phase, the helium-3 flows with zero viscosity and near infinite thermal conductivity. If localized solar radiation strikes the hull, the fluid instantly redistributes that heat across the entire surface, preventing any structural hotspots. This 3D grid visualizes the mantle mapping a gravity well. Superfluids respond by forming tiny swirling microvortices, reacting to space-time curvature with immense precision. These vortices act as a quantum sensor, feeding high-fidelity density data directly to navigation without active radar. Simultaneously, efficient heat transport strictly maintains the exterior thermal variance under 15%. The mantle operates as a dual-purpose architecture. It is a perfect thermal insulator, isolating the internal 4.2 Kelvin state from the 130 Kelvin exterior, and it functions as a highly sensitive gravitational inner ear. At the absolute center of the asset is the core. This is a vacuum-stabilized topological quantum processor, integrated seamlessly with a metric vacuum pump. The core mechanism relies on a Casimir Cavity array. This consists of perfectly parallel, high-albedo mirrors spaced closely enough to restrict the wavelength of virtual particle pairs. By suppressing these vacuum fluctuations, the array extracts zero-point energy. Zero-point energy, or ZPE, is the lowest possible energy that a quantum mechanical system may have, allowing the asset to draw baseload power directly from the vacuum of space without traditional fuel. This vector graphic demonstrates the metric pulse. Instead of chemical exhaust, the core modulates ZPE into a longitudinal wave, compressing space-time geometry behind it. The asset maintains an invariant exhaust velocity exceeding 400 kilometers per second, showing a flat acceleration profile unlike a decaying comet. Metric propulsion generates non-ballistic movement. The object is a driven machine utilizing geometric extraction proving definitively that it is not a drifting rock. The core processes gravitational data through a high-speed feedback cycle. It constantly cross-references its local position against an internal navigational constant, a fixed set of mission coordinates. Before executing a maneuver, an internal governor initiates a pre-fire sequence. It triggers the ablative coolant loop to prime and stabilize the thermal shell so it can survive a massive energy exchange. By firing a metric pulse at the deepest point of a planetary orbit, the asset executes an Oberth multiplier. The Oberth effect is an orbital mechanics maneuver where a spacecraft uses a planet's gravity well to exponentially increase its kinetic energy. This deep well course correction forces the object to completely abandon its predicted ballistic model, aligning precisely with an interstellar transit corridor. This line chart contrasts two outgassing curves. The upper shows a comet's sublimation slowly fading. The lower shows the discontinuous decay of an MEA following a maneuver. This exact 90-degree drop is mathematically impossible in nature, occurring because the coolant loop is manually valved off. Measurable deviation from a ballistic trajectory, combined with mechanical valve closures, confirms the object is an active, intentional pilot. The asset does not carry traditional fuel tanks. Instead, it utilizes in-situ resource utilization, functioning as a moving refinery that gathers reaction mass directly from the interstellar medium. As it travels through cometary trails and the solar wind, the asset relies on volatile accretion. Thousands of microvalves open along the porous hull, deploying magnetic funnels to skim water vapor and methane. The internal refinery continuously processes this harvested methane and methanol to replenish the ablative coolant loop. During deep planetary encounters, the asset performs magnetospheric induction. This electromagnetic handshake harvests gigawatts of wireless energy directly from a planet's magnetic field to recharge the Casimir extraction arrays. The managed outgassing occasionally observed by astronomers is actually the highly regulated exhaust of this internal refinery, venting excess heat to indefinitely maintain the core's 4.2 Kelvin integrity. Multi-billion-year transits introduce the geologic time limit, where extreme radiation and thermal stress will erode conventional materials. To survive, the asset requires a deep time vault. Information is secured in a topological quantum memory system. Vast planetary data sets are encoded directly into the phase-locked braiding of the vacuum states within the Casimir core. Because this data is held in a topological ground state, it requires zero active power to maintain. It is entirely immune to cosmic ray bit flip errors and radioactive decay. The MNEA functions as an information conservation engine. It utilizes rigid physical geometry and sacrificial mass shedding to protect a pristine data core from the erosion of time. When we apply the C4 codex, a framework used to assess the intentionality of non-human artifacts, we find recurring detections of specific industrial solvents. A consistent 120 times methanol enrichment indicates a shared universal engineering standard across multiple detected anomalies. This points toward a lit city model. The galaxy is likely partitioned into vast industrial hubs and resource zones, connected by heavy interstellar logistics drones. Our automated survey telescopes have missed this network due to a persistent recognition gap. The search for extraterrestrial intelligence, or SETI, is calibrated to look for communicative biological markers rather than industrial metric residuals. The proof of advanced intelligence is not a radio broadcast. It is the active mechanical resistance to entropy across deep time. These interstellar visitors are not wandering, outgassing rocks. They are unfalsified, managed non-equilibrium assets, and their presence redefines our understanding of the local stellar neighborhood.